Welcome to the first video about the Pythagorean theorem. In this video, we're going to go over some definitions and then do two examples. To start with, the Pythagorean theorem applies to right triangles. And a right triangle is a triangle that contains a 90-degree angle or a right angle. Often that is denoted with a little square in the corner of the triangle to show 90 degrees. The hypotenuse of the right triangle is the side opposite the right angle. It is also the longest side of the triangle. Finally, the legs are the sides of the right triangle that meet to form the right angle. So the two sides other than the hypotenuse. So those definitions are used as we go on to talk about the Pythagorean theorem. The Pythagorean theorem says, for a right triangle with legs A and B and hypotenuse C, if you take the square of each of the legs and add those quantities together, it will equal the square of the hypotenuse. That relationship is called the Pythagorean theorem, and that is the relationship we'll be using to solve for an unknown side of a right triangle. So let's go to an example where we can use that. Example 1. The legs of a right triangle measure 15 feet and 20 feet. Find the measure of the hypotenuse. So it's always nice to have a little sketch to work from. So I'm going to label my sketch. My unknown hypotenuse I will call C. So the Pythagorean theorem says a squared plus b squared equals c squared. I'm going to be solving for C, I'm going to be solving for C, and so I'm going to actually reverse that formula and put the c squared on the left-hand side, so c squared equals a squared plus b squared. I'll now substitute my values in for A, I will put 15, in for B, 20. At this point, I can do the calculations for the right side of the equation. I get to the point where c squared equals 625. We know to solve for c, we would need to take the square root of each side. Normally, when we take the square root, we'd have a plus or minus case. In this case, plus or minus 25. But since we're solving for the side of a triangle, it does not make sense to have a negative side. So we're going to throw out the negative option, and we will just be left with c equals 25, and our units here would be feet. So when we use the Pythagorean theorem and we take the square root of both sides in our solving process, we do not need to include the negative case, because for this real life example, the negative case does not make sense. Let's do another example like this. Example 2. The width of a rectangle is 24 centimeters. The length is 45 centimeters. Find the diagonal of the rectangle. I'm going to again draw a picture and draw in the diagonal. We know that a rectangle has 90-degree angles. So when we draw in the diagonal, we see that we're really creating a right triangle. And the diagonal is the hypotenuse of that triangle. It is across from the 90-degree angle. So we're going to put our 24 centimeters, 45 centimeters, label our picture, and now I will set up my Pythagorean theorem. I'll substitute my values in for A and B, and continue working out that right side of the equation. When I get a single value on the right-hand side, I'm ready to solve by taking the square root of both sides. I'll do that right on my calculator, and it turns out 51. The units on this particular problem were centimeters, so the hypotenuse, which is in this case the diagonal of the rectangle, is 51 centimeters. In the next video, we're going to do a couple more examples, but we're going to move on to see what we should do if the value that comes under the square root is not a perfect square, so we're not getting such a nice whole number answer.